Question 4. Let f be a twice differentiable function on the closed interval -4 to 4, with f of 2 equal 3. The graph of f prime, the derivative, is shown. Part A. For x greater than 0, the function g is defined by g of x equals f of x minus ln of x. We want to find g prime of 2 and the work that leads to our answer. So g of x equals f of x minus ln of x. So g prime of x, that's going to equal f prime of x minus 1 over x. Now to get g prime of 3, we're going to substitute 3 in for x. Now since we want, don't want 3, we want 2. So since we want the value at 2, we're going to look to our graph and we're going to see 1.5. But I'm going to just leave it as 3/2 because that leaves us with a value of 1 for g prime of 2. Now for part B, it says find all values of x on the open interval 0 to 3 at which the graph of f has a point of inflection. Now again, we want to know when f has a point of inflection, but we don't have that. What we have is the f prime graph. So we have to ask, when f has the point of inflection, what does f prime have? F prime has an extrema. Whether it's a maximum or a minimum doesn't really matter, because what we want, in order for it to have a point of inflection, is that the next derivative changes sign. That's what has to happen. Now, since we're only looking at the interval from 0 to 3, we're only concerning ourselves with this portion of the graph. Now notice it's the open interval, so we're not considering the point at 0 or the point at 3. We're only considering all the points in between. So we say at x equals 1, f prime of x has a maximum, which by definition means that f of x has to have a point of inflection. Part C. For the closed interval -4 to 4, on what open intervals, if any, is the graph of f both increasing and concave down? So we have two behaviors we have to track. The first one is when f is increasing, that means f prime is positive. So looking on this entire graph, we want to know where is f prime positive. Well, it's positive from -2 to 3, and then from 3 to 4. So the open interval -2 to 3, and then the open interval from 3 to 4. But then we have to consider when is it concave down. So f is concave down. That means f prime is decreasing. So we have from -4 to 3, -4 to -3, and then from 1 to 3. Those are the intervals where the graph is decreasing. So we want to know where is the overlap. Well, let's see, from -4 to -3, that doesn't overlap with this interval at all. So next I go from this interval to this interval. Here we have some overlap. And if it helps, one thing you can do is draw out a number line. And then in between, let's see, I'm going to label this. So 2, -2. So then I've got from -2 to 3, and then from 3 to 4, and then from -4 to -3, and then from 1 to 3. So here's where we have our overlap. So on the interval, now notice that they told us, they say on what open intervals. So we have to be sure that we justify this as an open interval. So we say 1 less than x less than 3, and you can use parentheses if you want to. F prime is positive and decreasing. And that's our justification that gives us that f is increasing and concave down. Part D. From -4 less than equal to x less than equal to 4, find the value of x at which f has an absolute minimum and the value of x at which f has an absolute maximum. Notice that they're not asking for the y values, but what we have to do is we have to give reasons for why we pick the values that we do. So when we have absolute maximums, absolute minimums, we need to consider our candidates. So we need to consider our x value and then our f of x value. So we have our endpoint, -4, and then a critical point at -2, then another critical point at 3, and then our last endpoint is at 4. Now, how are we going to come up with these values? Well, we have to use the f of 2 equals 3 as our starting point. And we're going to have to use that for all 4. But then, onto that, we're going to add in a definite integral. So here, this is going to be the integral from 2 to -4 of f prime of x dx. Now, because this integral is somewhat upside down, I'm going to flip it. We've got f of 2 minus the integral from -4 to 2 of f prime of x dx. For the second one, here it's going to be the integral from 2 to -2 f prime of x dx. I'm going to flip this integral. So we have f of 2 minus the integral from -2 to 2 of f prime of x dx. Now for the third one, this integral is going to go from 2 to 3. So I have no need to flip this one. So I'm just going to leave it as is. Same thing here with number 4. We've got 2 to 4, f prime of x dx. So now the issue is, okay, these are what the values would be, but we have no way of figuring out the area. But what we can do is we can compare. We can compare this integral and this integral. And then we can compare this integral and make a relative comparison. Because if you notice, the way they wrote this question, 2 of them are being subtracted, 2 of them are being added. So it's kind of set up like, okay, compare these two, and then compare these two. So looking at the integral from -4 to 2, okay, so that's going to be this area all the way to here. Well, that's going to clearly be positive. But if I go from -2 to 2, that's going to be even more positive because we're not including this negative area here. So what I'm going to say down here is I'm going to say, whoops, wrong color. Let's use the right color. 0 is less than the integral from -4 to 2 of f prime of x dx, which is less than the integral from -2 to 2 of f prime of x dx. Therefore, which one is smaller? Well, that means which is the bigger number? This one. I'm subtracting this one. So therefore, f of -2 is less than f of -4. So this one is the smaller number. Now let's say the same thing for f of 3 and f of 4. So if I go from 2 to 3, that's a positive integral. But if I go from 2 to 4, that's an even greater positive integral. Let's see if I can fit this down in here. So 0. So the integral from 2 to 3 of f prime of x dx is less than the integral from 2 to 4 f prime of x dx. Therefore, we can say that f of 3 is less than f of 4. Now, because all of these are greater than 0 and because these two are being subtracted, if you really wanted to, you can put these together as a single inequality and say f of -2 is less than f of -4, and then keep going, which is less than f of 3, which is less than f of 4. Because all these integrals are positive, and so because the first two integrals are going to be subtracted away from f of 2, these two are going to be smaller than these two right here. So therefore, where's our absolute maximum? Well, we said f of 4. And so x equals 4 is our absolute maximum. That's the absolute max. And x equals -2 is the absolute minimum.